It's quite the sight we have here. Pistons, bearing caps, camshafts, parts all over the place. So what ended up happening was this block had this crankshaft in it that snapped. Two of the bearing caps snapped. So I got this, I had this spare engine on another property for the last couple of years, and it was seized, and it turned out it had a spun connecting rod bearing. All the journals on the crankshaft otherwise, which is over there, look to be in good shape. So I'm going to use this crank. There you can see where the spun bearing was there. I'm going to use that crank with that block. I was hoping for a good cylinder head off that block, but this one's got a crack on number 1, 3, and 4 in between the valves. Fortunately, the customer's cylinder head has no cracks between the valves, and that's that one right there. It's all stripped down. So we're kind of doing a bit of a piecemeal approach here. Going to take the crank, the pistons, connecting rod assemblies from this block and use them there. Cylinder head from the customer's engine and camshaft are going to be used in this block here as well. All the good parts are going to be used in that block. This camshaft apparently has about 180,000 K on it. I do have to measure it still. This one's got 370,000 K on it, so which is from this block here. So that's kind of where we're at right now. Lots of parts all over the place, getting pretty messy, but I've got to the point where I can take things to the machine shop now and get the block cleaned and have the cylinders inspected, and the plan is to give them a hone, clean up these pistons, put some new rings on, all new bearings on the connecting rods, the main bearings for the crank, new cam bearings will be installed. These ones have been removed already here. And yeah, should be a pretty awesome engine after. And the cylinder head will get new pre-combustion chambers and a new head gasket, obviously. Whenever you remove anything, you don't reuse the gasket. So yeah, that's kind of where we're at now. So we're back at it here. Before I get too carried away, I thought I would show the connecting rods. Got new connecting rod bushings here, new pistons, new piston pins. These two have been assembled already. Cylinder head pressure tested, bead blasted, primed, painted. And we've got the block here all painted and ready for action. So yeah, gonna finish assembling the pistons and then put the connecting rod bearings in and put the crank in the block and get this thing on its way. Cranks installed, caps are all torqued, obviously new bearings. Now we're going to flip it over and work on installing the pistons. Just about to put the oil cooler on. Got the front basically wrapped up, timing cover, oil pump, etc. Injection pump, engine mount here, alternator mounting bracket here. So yeah, we're making some progress. New front oil seal, new pistons, new liners. Let's get that oil cooler in. So here's where we're at, just about to put the head gasket on and the cylinder head. You can see the block heater is installed as well. The EDIC, which is the electronic diesel injection control unit, along with the rod. And over here we have the cylinder head. Just put the valves in. New valve stem seals, new pre-combustion chambers. Obviously I'll be removing the tape, and then that's going to be installed on here. Oil cooler, filter housing, alternator bracket. So here we are, got the lifters in yesterday, finally, so I was able to install the push rods, the rocker assembly, the push rod side cover, which is this black cover with the road draft tube coming out. I made up new lines for the turbo. As you can see, there's the fitting I put in, and then there's the one the other shop put in, pretty nasty, right in line with the oil filter, so the hose was going to be at a horrible angle, so just put a brass plug in there for now. Now, new oil pressure sending unit, and I just mounted the power steering pump. Just need to torque this bolt here. Got the hardware all torqued, and the alternator bracket is done. Ooh, there's a tiny, 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 tiny little ball that goes on the end of this thing, and it was stuck on the magnet in here. Good thing I noticed that. So here's what happens when you don't give a crap about your work. The shop that did this engine swap did not swap in the correct heater core line. The result is this hose is almost burned all the way through because it was resting right up against the exhaust. The 3B engine has the exhaust on the passenger side, whereas the 2F engine has the exhaust on the driver's side, so this isn't an issue. As you'll see on the following photos, I had to cut a hole in the firewall for the correct line, and then you will see the correct line soldered to the heater core. Yet another issue I had to deal with on this job was I had to fabricate a bracket, which you can see in the photo, to support the turbo exhaust manifold. The shop that sells these kits here doesn't supply a bracket to support the manifold. Now, Toyota did supply a similar bracket on the 13BT engine, which is the factory turbocharged version of the 3B. So in order to keep things as factory as possible and to prevent any premature cracking of the manifold, I always install these brackets. It's a no-brainer. Why wouldn't you install one of these brackets when you're installing a turbo? Toyota thought it was important. And if you think about it logically, you've got this turbo, which is like 15, 20 pounds of weight, sitting on the end of a manifold. Well, obviously there's going to be some undue stress on that manifold. So adding that bracket there to support it seems like a really good idea. Well, there was another issue I had to deal with. As you can see in the photo, the wastegate actuator for the turbo, I had to make a bracket for that because for whatever reason, the turbo kit that the customer had or was supplied came with a random wastegate actuator that had been cut and mounted to the compressor housing in such a way that it was sitting at an angle and the bolts were ripping the threads out of the compressor housing. As you can see in this photo, the wastegate actuator and bracket are now installed correctly. Another issue I had to deal with was the intake side of the compressor housing, the round tube part that you can see in the photo that the hose would go onto from the air cleaner. Well, the shop had a piece of exhaust tube welded to a plate of steel that was bolted to the compressor. So I had a machine shop make the round pipe section on the end of the turbo there. It was then press fit and TIG welded in 3 different spots. So dealing with the engine is one thing, and then you road test a vehicle, and then you find problems elsewhere. This is one example. The rear diff seal was leaking like crazy. So that had to be replaced as well. Well, here's a few photos of the engine as I was finishing the assembly. All I can say is this was one heck of a job. There was lots of unexpected surprises, but I got her done, and it runs well. And next is a video of it running. So in this video, I'm obviously driving. My friend is videotaping. And I'm just testing out the turbo performance, trying to dial things in. And just enjoying driving the truck after all that work. So you can see the gauges. I'm just coming up to a stop here. And then I'm going to be turning right and accelerating a little bit. How much boost you produce really depends on how much you press the accelerator pedal. So I can gradually bring the boost up by gradually pressing the pedal. And your EGTs will also react to your foot. You really don't want to bog down an engine. What I mean by that is you don't want to accelerate in a high gear. You're better off shifting down. It's less stressful on the engine. Just to be clear, I wouldn't normally drive this way, and I don't recommend that you do either. Anyways, I hope you enjoyed this video as much as I did making it. We'll catch you in the next video. Thanks for watching.